Point 2. Today we're looking at graphing f of x is equal to ax squared plus c. Now if you recall from yesterday's video, we looked at just graphing ax squared, and we specifically looked at what that a value did. That a tells us how much of a vertical stretch or shrink we're going to apply to our parent function of x squared. Well, today our job is to figure out what that c value is going to do to the graph of that parabola. Let's jump in and get started. First of all, c can be a positive value. When c is greater than 0, it's positive, and that means it's going to be a vertical translation c units up. All right, now when c is negative, or in other words, it's less than 0, it's going to be a vertical translation c units down. The vertex of the graph of that function, ax squared plus c, is going to be at the point 0, c. It's going to move from the origin either up or down based on whether c was positive or negative. The axis of symmetry, however, is still going to be the y-axis, and that's the vertical line x equals 0. All right, one more thing to note. The 0 of a function is the value of x that makes the function equal to 0. In other words, the y will be equal to 0. In order to find the zeros of a function, you're going to set that function equal to 0 and solve for x. That will make more sense when we do our examples. All right, starting off with example 1, we have the graph of g of x, which is x squared minus 4. That's going to be graphed here in blue, and our parent function y equals x squared is graphed in black. We want to compare it to that parent function. Well, first of all, it looks like it's a transformation, or a translation, I should say, a translation of 4 units down. Now, that should make sense because it looks like, if we go back to the equation, our c value here would be equal to negative 4. The vertex now slid down from 0, 0 down to 0, negative 4. The axis of symmetry, however, is still that vertical line through x equals 0. And so that's that dotted vertical line there. That's the reflection line of symmetry. All right, how about our parabola? Our parabola is going to open up because our a value here is equal to positive 1. And you can see that there's nothing in front of that x squared term, so it's just a equals 1. All right, let's grab some points here. What happened to our points from our table? Well, if you look at our parent function here, all of these points get slid down 4 units. In other words, we subtracted 4 from the y's. So what was at 0, 0 is now at 0, negative 4. What was at 1 over and 1 up is now down here at 1 over and negative 3, and then 2, 0. Okay? Since it's reflection symmetric, these points are going to be the same on the other side. All right, let's look at example 2, and we're going to do a little bit more complicated graph. Now remember, we're graphing all of these by hand just from what we know about our parent function and our transformed function. So here we see we got y equals 2x squared plus 3. Our a value is equal to 2. Our c value is equal to positive 3. Well, our parent function is graphed right here. And we can see it goes to the origin, and 1 over, 1 up, 2 over, and 4 up. We want to compare this by understanding the transformations that happen. So first of all, a tells us that it's a vertical stretch by a factor of 2. All right, and then the positive 3 here represents that it's a vertical translation. Vertical translation up 3 units. We'll say up 3. Okay, so that's going to help us find our vertex. Our vertex is going to be slid up 3 units to 0 over and 3 up, so I can plot that point here on my new graph. My axis of symmetry is still the same. It's this vertical line, x equals 0. And so that's going to help me find points on both sides of my parabola. I know that it opens up because a is equal to positive 2. Now remember, this 2 helps me to determine more points on my parabola. Instead of going 1 over from my vertex and 1 up, like I would do on my parent function, I'm going to go 1 over and 2 up because my a value is 2, and that tells me that vertical stretch. Next, I'm going to reflect that line over my axis of symmetry, and so there's another point on my graph. So I've got 3 points. That's enough to graph my parabola. and I'm going to fill in my table here. So 0, 3, 1, 5, negative 1, 5. Now, what about these negative 2 and positive 2 points? All we need to do is actually plug that point in for our x. So 2 squared is 4, 4 times 2 is 8, and 8 plus 3 is 11. So these 2 points are at negative 2, 11 and positive 2, 11. That's off our grid, so we can't really plot that. So we're just going to do the best we can to draw our curved line through those 3 points, and there's our parabola. All right, moving on to the back side of our notes for today, we want to find the zeros of the functions. Remember, that means we're going to substitute 0 in for y and solve for x. So 0 is going to go in for y, and now I have x squared minus 4 on the other side. I'm going to solve for x by adding 4 to both sides, and that gives me the equation 4 is equal to x squared. I now need to undo the x squared by taking the square root. And remember, when you take the square root, you're going to have 2 answers. You're going to have both the positive and negative values of the square root of 4, which are 2. So my 2 solutions here are positive and negative 2. Same thing for part B. We're going to substitute 0 in for y. So we get the equation 0 is equal to negative 2x squared plus 50. We'll start by moving the 50 over to the other side by subtraction. That gives me the equation negative 50 is equal to negative 2x squared. Now divide off the negative 2, and I'm going to come up here and finish. I have now x squared is equal to negative 50 over negative 2. That's positive 25. I got to get x by itself, so let's take the square root of both sides. That leaves me with both the positive and negative values of 5 for my zeros. Moving into example 4. We've got a little bit more of a complicated graph, but you can do it. You are pretty well versed here in how to find all of these. We have the parent function, f of x equals x squared, and g of x is the transformed. So we have an a value here of 2 and a c value of negative 18. Let's describe that transformation. Well, this is going to be a vertical stretch by 2. And it's going to be a vertical translation down 18. All right, I'm just going to write that as negative 18. So that you should say down 18, negative 18 is fine. So that means the vertex, I'm going to skip down to this one here, the vertex of this parabola for g of x is 0, negative 18. All right, we'll get to that here in just a second. So it says to graph both the parent function and g of x by hand on the same xy plane. So hopefully by now you're good at finding the values of that parent function. Its vertex is at the origin, and then 1 over and 1 up, 2 over and 4 up. And then remember, it's symmetric to that y-axis, so those points just get reflected over that y-axis. There's our points of our parent function. All right, and that's y equals x squared. Next, we're going to graph our g of x function. We said our vertex is way down here at negative 18. All right, and we are going to also find a couple other points. Remember, our a value here was 2. So when a is 2, that tells me my parabola opens up. And to find some more spots on that parabola, I'm going to go to the right one, and I'm going to go up 2. Because that point, 1, 1, on our parent function gets stretched vertically by 2 units. All right, that means this point here, negative 1, negative 16, is also on the graph. And I'm going to do one more set here. I got another point. If I go to the right 2 and up 4, that means it's got to be stretched to the right 2 and up 8. So that's going to put me right here at 2, negative 10. Reflect that point over. And there we go. All right, so I have enough points now to graph my parabola. Let's see if I can get this thing. Yeah, it's kind of hard to do with this pen, but you get the idea. All right, our last question here asks us to find the zeros of g of x. So remember, we're going to substitute 0 in, and then for our y, I should say, we're going to substitute 0 in for our y, and then we're going to solve for x. So let's start by adding 18 over and then we'll divide off our 2, and that gives us x squared is equal to 9. Taking the square root of both sides gives us, that gives us positive and negative 3. There's our 2 zeros of that function. All right, in our final example for today, we're going to put this into the real world context. Let's say we have a function f of t that's equal to negative 4.9 t squared plus some variable h. It represents the height in meters of an object that is dropped from an initial height of h sub 0 after t seconds. So here it says to find and interpret, this is supposed to say f of 2 when your initial height was 50. All right, so we are going to substitute 2 in for our t value. That gives us negative 4.9 times 2 squared plus our initial height, which in this case is 50. All right, when we do that, we've got to follow order of operations. That's negative 4.9 times 4 plus 50, and that results in 30.4. Now, this is in meters, and this represents the height of the ball, or whatever it is we dropped. If we dropped an object, it might be a penny or a water balloon. Height of object after 2 seconds. All right. Let's do one last example here. Let's say you drop a coin now from a height of 44.1 meters. I want to know how many seconds does it take for that coin to hit the ground. In other words, the coin will be at 0 feet above the ground if it falls at negative 4.9 t squared seconds plus 44.1, because that's the initial height. All right, so take a second, pause the video, and solve this. In other words, what you're doing is you're finding the zeros, and we'll check your answer in class.